Hi, I'm really nervous. No, not. Okay. My name's Jes. I make algorithmic art, like you just saw. I'm going to show you a train of thought I've had over the last few months about some technologies that are ubiquitous because they're in the web browser that a lot of people, even web developers, might not know anything about. One of them is Webgl, which lets you write code that runs on the graphics card, right? So a Webgl program has two parts. One lets you render points in space. The other does pixel color values, vertex shader, fragment shader. Together, you make a 3D object with colors, right? You can do 2D graphics by rendering a flat plane and then painting a surface of that. And there's a bunch of hobbyists to do that. This is from Shader Toy. It's a community of people who share 2D fragment shader art. And a lot of them use that to implement 3D graphics, so they're doing 3D graphics on top of 2D graphics on top of 3D graphics for some reason. Okay, the other technology is web audio, which is where you make a graph of audio components, virtual audio components, and chain them together and do a bunch of signal processing stuff that I don't understand at all. But there is a really simple thing you can do where you just write JavaScript directly to the audio stream. And so this is the Hello World program of web audio programming. I'm just filling the buffer with a sine wave, time in seconds times 2 pi times 440 hertz. That's concert A, okay? So the neat thing about audio is if you want to combine sounds, you can just add the math together. So this is 3 sine waves, okay? So audio can be thought of as a function from time to a numeric value. In digital world, you wanted to talk about samples per second. CD quality is 44,100 samples per second. If you're writing C, you could write a tight loop that did 44,000 function calls per second, but in JavaScript, that'd be crazy. So instead, you make a frame of audio, an array, going a little bit into the future every time. And so the default is 1K of samples per second. So then your function's only getting called 43 times a second, which is much more reasonable. Okay? So analogously, video is a function from time to a 2-dimensional array of color values. Okay? And so I was thinking about 43 frames a second and how that is like right in the range of reasonable video frame rates. And I was starting to think, is there a way to sort of bridge the gap between those two concepts? And what I came up with is if you throw away the color data and you're just doing black and white, the data structures look a lot more similar, right? So each row of pixels is basically a frame of audio. And since adding 2 sounds together lets you play them at the same time, if you just sum the columns, you're playing all the pixels. And so I wrote code that does that. This is the whole thing. Writes a frame of GL, reads the pixels off the graphics card back into main memory. That's actually kind of slow. Iterates over the columns, summing them up. I'm just adding RGB together to get grayscale. Some algebra to scale it because it's integers versus floating point. And this is a fragment shader that has that same sine wave, right? But now x coordinates is a part of the time calculation. And instead of just outputting the value, I'm using the y coordinate to decide whether to show a black or a white pixel. So that looks like this. That's a picture of a sine wave and the sound of the same sine wave. Okay? So why is that moving? Well, a sine wave has a frequency, so it has a length and time. So that's a number of time samples, so that's a number of pixels. The window is a certain number of pixels, so every frame is a little offset from it because it doesn't fit perfectly. But you can make a wave that fits perfectly. That's this 43 hertz again. Go ahead and rumble. You can take it out a few octaves to make it more like a sound. It's kind of a weird tone. It's a little flat from an F. It's not really a musical tone, but you can still do music with it. And that's because music's all about ratios. Usually we think of, in modern music, this is the 12th root of 2, but I like the integer ratios better. It seems more clear to me. Okay, so I was thinking about this frequency, 43 point blah, blah, blah hertz. It's really weird, right? It's CD quality over 1K, over 2 to the 10. It's like, wow, maybe no one's ever used that for anything. It's the frequency of a virtual instrument. It's the resonant frequency, like it was a flute or something. And it's really weird that a virtual instrument would have that. I was like, maybe no one's even discovered that number before? That's not true. There's this website by this chiptunes artist, Adventure Kid, that has all this amazing synthesizer math. It's mostly over my head. But another thing he has is he has this concept of single cycle waveforms, which are shapes you can use instead of sine waves, something repeating patterns that you play that make a tone with a different timbre. And he distributes them as .wav files, as audio files that are only 600 samples long. So there's a tiny fraction of a second. And you repeat them and you get a note. And I was like, I want to listen to that, but I don't have a synthesizer. But if I wrote a script that converted WAV files into images, and I displayed those images in the browser, I could hear what they sound like. So I wrote a Ruby script. These are some of the sounds from that pack. The white part is positive numbers, black part's negative values, and gray is neutral, right? So those are all the same pitch, but they're different timbre, right? So while I was doing that, my friend Ashley, who's here, sent me a recording of her baby making cute baby noises, baby Iris. And so I did the obvious thing with that. And then so I cropped that out as a nice repeating pattern, right? So I cropped it out. Okay. But it's part of a human voice. So I was pretty excited by that, and so I got out my cell phone and I went, ah, ee, oh. Okay, so I'm gonna do what this says. So I didn't want to. That's great. I didn't want to write a whole piece or instrument that exists, so I thought I'd just make a short song each voice, all different lengths of sound. That's weird. And so each one is repeating, and they'll have different links to the race, different time factors, so they have to sync with each other and gradually after they regrow possibilities. I thought that was pretty clever. But I'm pretty sure someone else thought of that before. So I asked a friend who's a music major, what do you call it when you do that? She said, oh, that's minimalism. That's that's exactly how Steve Ray would know it, or like Terry Riley. So I have some ideas for where you can take this in the future. There is actually a Webgl API. You can hook up real instruments to this. I've also been thinking that there's other synthesizer map out there that can implement regular geometries, like if it wasn't just rectangles, it was like on a circle, then every circle would have a different resonance frequency. This is a visualization of rounding error of point numbers. It looks like something, so it must also sound like something. And then if you're thinking about video and audio signals, you can eventually remove